Maria. Hello to everyone. I'm Andrey Zavadskiy. I'm from Russia, and today we will talk about database modeling, about the first two stages, conceptual and logical design. Some words about me. I'm a solution architect. My interests are SQL Server, Entity Framework, Backend, and MVC, also Web API. Here you see my contacts. So if you have some questions, you can write me through the blog or via social networks, and I will answer you as soon as possible. What is the database modeling? Usually it is divided into three stages: conceptual, logical, and physical. We will talk about the first two stages, about conceptual and logical design. You can ask me, what's the difference about conceptual design and logical design? The difference is about the level of detailization, about how many entities and attributes you consider on the stage, and to what person you are talking. When you are talking to a business user, a business owner, or a product owner, it's a conceptual. When you talk about with a developer, it's a logical design. There is no universal recipe, no universal solution for every database. So many times you need to consider what is good and what is bad in this situation. And many times you will say, it depends, yes. So to make a good consideration, to make a good decision, you should know three things. You should know your model, your entities, your relationships. You should know your data. So how many records is stored, will be placed in your database? 10 rows or 10 million rows? How this data will be used? Which query your application will put against your database? And one of the important things is to predict the business requirements, the business needs, what will be in the future. So, okay, the first stage is conceptual design. Conceptual model involves the most important entities that are very necessary for the business. And you discuss with the business what will be in this case or in that case. You decide on the most important fields, columns, attributes, and the relationships. How many records will be in this case or that case, one or many? It's the one of the most important questions in database modeling. Usually we use an entity relationship diagram to draw the whole picture of our model. So when you talk to the business, you could not draw every table, every entity. Maybe you have 1,000 entities and it could not be pictured on the one page. So you divide it into small parts and discuss it with business. Okay, this is a sample diagram for employee. So I have a person, entity, employee, job. The person has some position in organization. On this picture, you should not write all attributes. It's enough to show only most important. You can discuss with the business. Look at the red line. You can discuss with the business. Do you have a global dictionary of positions in your organization, or do you have a dictionary of positions that can be dependent on division? So in one division you have one set of positions, in for example for IT division. In financial division you have another set of positions, so you will have to implement some relationship between these two entities. Okay, some people can draw an UML class diagram to show the relationships between the entities. For example, if I have a for university, we have employee and we have a student. Okay, so we can imagine that they have a base class like person. So we inherit employee from the person, and we can inherit student from person. Is it right? I think no, because one person can be a student and after he graduates from the university, he can be teacher, so he's an employee. Maybe this person can be a student and an employee at the same time, and a person could not be an employee or student. For example, he just wrote some work or some article for the university, and you only need to write him as an author of that article. So it would be better that you have a separate entities for person, for employee, and student. Okay, another chance. When you have an organization, enterprise, company, firm, and let's think about bank. Bank is another kind of organization or company. It has they provide financial services for money transfer. So we can consider them in the class diagram that bank is inherited from organization. Yes, yes. So we have two possibilities to implement it in database. So we can have one entity. I name it as a universal entity. So we have a universal set of attributes for any kind of organizations. For any company that makes software or provide some services, and for banks. So we have red attribute is bank. So it's a discriminator that shows that this organization is bank. So we have some attributes specific to bank organizations like SWIFT. Another chance is when you have two separate entities. One entity for organization and one entity for banks. Is it good? In some situation, yes. So here it's your decision, and it's your responsibility to make this decision. When I talk about entities, I usually divide entities into two types. The first type of entities represents objects or states. It represents some unique objects from the natural world, from virtual world. It's an object of information. They are very rare, changed, and it usually leads to when we have one record for this unique object. But when I see that I have an entity, some object of information like job, and I see that it have dates. It starts from one day and ends in another day. And then I have another thing, another job, another position from this organization, from second organization. So when I see these entities, I understand that I will have a time series. So I have a start date and end date. So I will have many records for one object, many records for my job history. So one of the most important questions that you need to ask from the business: do you need to have a history of what was 1 year ago, 10 years ago? So the business should tell you how much history and how much data do you need to save in your database. Maybe some facts that something was changed. Maybe you need to log who has changed the data and how, when it was made. But in many cases, you need to save all attributes, all changes. So how can we do this? Here we can use a good solution that was developed by IT World. It is called slow changing dimensions. It was taken from data warehouses. So you can open this link. And I briefly show you the main types of changing dimensions. And you can take it for considerations. Which type do you want to implement in your database? Type 0. Nothing is changing. So we store the birthday of the person, and it will never change. Is it good? Yes. Yes. Type 1, override. So we have a one row for one person. So Anna is a junior developer, and after some work, she becomes a middle developer. Is it fine? Yes. But we have no history about what was before. We only have the current value. Type 2, okay. We store all versions of the data. So one row for junior developer, the second row for middle developer. Yes, good. But here you need to fetch too much rows to find the current row. So let's consider that Anna has 100 jobs before the current one. So you need to fetch 100 rows to find the current position. Type 3. We place another column, another attribute to store the previous value. It's like a type 2, but here in type 2 we have 2 rows. In type 3 we have 2 columns for current position and previous position. Is it good? Yes, but I want something more efficient. Type 4. Sometimes it's the best solution to store the history. You have a base table where you store the current value. Okay, Anna is a middle developer. And you have a history table when you have all history, including the current value. It will be much easier for you to find the current value from the base table and to get all history from the history table. If you don't have a current value, the last row in history table, so to get all the history data, you need to union these two tables. And it could not be very convenient to make a union between two tables. When I talk about changes, please consider that changes can be less important and more important. Some changes can be like a typographic input error of the person who entered the data, and it has no much value for business. Maybe the girl could change her last name after marriage. Is it important for business? Maybe, but it's not so much important. But when you have a change in position, it's an important fact that some people are growing in our company. Okay, it's good. So maybe the boss wants a report. So how much people have raised in our company? Some changes and some errors could have negative impact on financial, on accounting. So if you end up wrong data in salary, you calculate wrong tax, so you need to change it before. So you have a incorrect financial reports. So think about the changes. Some changes can be business facts. So it's not easy to get reporting from history tables. So please consider that you need to save these business facts in another table. So when you have a change in position from junior developer to middle developer, so it's a business fact. So maybe you decide to store this fact in another table. So you have a change in job history and you have a fact in another table. So you can use these changes in your reporting, in your BI solutions or your data warehouse. Very important is how you will process data manipulations. sometimes some changes are not allowed, are not permitted after you close the financial year. So in this case, you need to make some correction in the current financial year. So you will need to place some ban to data updates. So in this time, in this case, you also will have to implement some revert operation. So you make an error in one step, so you need a rollback operation for this data. Also, it's very important which physical operations do you allow in your database. These can be hard delete or soft delete. Hard delete is where you delete the record, so you will never see it in your database. Soft delete is where you mark the row as deleted. It's very important when you have dictionaries, when you have master data. So you could not delete some data and forget about it. There is one important thing in database. It's archiving. No, it's not a backup. It's not a zip or some kind of copying your database to another storage. It's not a partition. No. It's where you place, you extract your data from your active database and place it in another place. For example, in the cloud. For example, in another database server, in another database center. So your application is using just a small portion of data. But you need to implement the possibility of to find something that was many years ago. So you can implement it in your database or in your application. For example, we have an application that have an active database. Okay, the database is growing very fast, and we couldn't afford to store it in our database server. It's very, very large, so we decide to store only the current financial year and the 3 years before. So how to get data for 10 years ago? So I need some way to query the database that can be located somewhere outside. Is it easy to do after you move your database to production? I think no. So it would be better if you predict this growth and implement some features in your application so you can query another instance. Okay, do we have some questions? No? Okay. Let's.
No. It was one about the coding, and I have answered that one, and no, not yet.
Okay, wonderful. Logical design. Okay. When we talk about logical model, it's a more detailed version of our conceptual database, conceptual model. So we go deeper to our entities, our tables, our attributes, relationships. Usually, the logical model is normalized to the third normal form. We will not discuss the normalization. It's another story. So, okay, this entity relationship diagram is the same as was in our conceptual model. But now I place all attributes, all relationships, and the attributes that will organize these relationships. Also, the most important thing is relationship, one-to-one or one-to-many. When we talk about entities, we need to ask yourself, do we have one value or multiple values? So if we have one value, it's a very, very good situation. It's attribute. But if we have multiple attributes, so we need to think, what will it be? It can be entity, it can be attribute with history, or it can be just attribute without history. Okay. Let's name. Every man and woman has a last name and a first name. Okay. The last name can be changed, for example, after marriage. Maybe I just want to change my last name because I just want to do this. Maybe I have a different spelling in my national passport and international passport. I heard there are situations when the one and only people has one name in one country and another name in another country because he has a dual citizenship. Okay, so which of three types can be implemented here? Entity, attribute with history, or just an attribute? When you make an application for casual service, for example, to order pizza or taxi, you don't need to store too much data. You only need a first name, maybe last name, and phone number. So when you have this, in this case, you may save only just one attribute. When we talk about the company and the personal system, so we need to store all data and all changes. So if here we can say that we need to save attribute without change history. But when we talk about in the state service, so we need a precise control on our data. So we need to know how many citizenships, how many passports, how many different spellings this person have. So in this case, I would suggest that we have one entity for person and another entity to store his last name and first name, and maybe it's his citizenship. Okay, another case is phone number. Okay, I have a phone number. If I order pizza, I just need first name and phone number. So I make my service to deliver your pizza, and I can forget about you, maybe. Uh, if I have some bonus card, so I need to store some data about you. Every person can have different, can have 2 or 3 phone numbers from different telecommunication companies. One phone number can be shared between different people. For example, if it's a corporate phone number, and if you say about telecommunication companies, this phone number can be transferred between you, another person, after you stop to use their services. So you have different implementations between attribute entities. So for the telecommunication company, you can have more complex relationships between owner, the person, the contract. It's where you have some rate plans or some usage, and you have a phone number. So you can have one contract, but you change phone numbers. So for telecommunication company, the phone number is an entity, and for pizza order, it's just an attribute. So it's not easy to say what will be the best solution. It depends. It depends on where your purpose is about. It depends on business requirements, and it depends on how much data will be stored in your database. That's whether you have one value or many values. In some cases, you need, when you have multiple values, you need to use an additional table. It's a separate entity. And when you have a many-to-many relationship, it is implemented in relations databases as a junction table. So you have a relation one to many between one table to this junction table, and the relationship many to one from the junction table to the second table. And another case is generalization. Maybe you can find a situation when you have some set of tables of entities that have very close meaning, very close a set of attributes, and you want to have just one place where you can place all this data. For example, documents. Okay. A person can have some documents, passport, social security number. An employee can have some documents, for example, in order to hire, in order to some job transfer. A student can have some documents. So you can decide that it will be better to place all this data in one big table. Is it good? Maybe. So a person can have a document, and an employee can have a document. So we have a relationship between different entities like person or employee to one table, that document table. In this case, we need to implement some kind of discriminator so that we understand that this document belongs to the person or to employee. Another case is when you have a separate tables for each entity. In this case, person have his own table for documents, and employee have his own table for documents that belong to employee for this kind of activities. Is that good? Yes, because when I need some data about person, I query the only one table, person doc. It can be much smaller than a one big table. But when I need to query data for person who is also employee and a student and something else, so I need to query all these tables, person doc, employee docs, and so on. In the previous case, when we have a one big table, so if I need some data about person, I need to query too much rows and take care about discriminator. So in this case, we have two possible solutions, and you can consider what will be best in your case. Another case when you have a one big table is when you have a very large set of small tables. Like some dictionary, when you store 5, 10, maybe 20 rows. So you can create 1,000, 5,000, 10,000 tables and store 5, 10 rows in this table. Another case, you can create one table, place all data in that table, and to query these tables on the filtering on the discriminator on the table name column. And it's your decision to use and to select which type of generalization you will implement in your database. In the conclusion, I'd like to say that always ask yourself if you have one or many entities, one or many attributes, one or many values. So please consider all possible things, all possible situations when you have what will be if you have a change in the last name, if you have a change in birthday, if you have a change in address. What will be if a person has a one address where he lives and also he has another apartment or apartment in another country? Do you need to account this? Do you need to store all the possible things, all the possible values, all the rows? So when you have the whole picture of your model, so you can decide on which restrictions do you want to place on your database. For example, okay, I have a person for pizza order, and I will save only just one phone number. It will be easy for me. I'll say, no, I want to save all phone numbers. Okay, so you understand that you need another table for phone numbers, and you need to join when you will query those data. So when you have some restrictions, you understand what are the pros and cons in your solution. So maybe you want to implement some denormalization or something, or some other kinds of to make your database to fetch the data more quickly. So, in my opinion, is one of the most errors that are made in database modeling is when you don't consider multiple values. When you don't consider that you have two persons in the order, that you have a person with two phone numbers or some other cases. So ask yourself, one or many? So you can consider your database and make a good decision. And don't forget, it depends on your situation on your business and your business requirements. Okay, do we have some questions?
No? Anyone on the line? Do you have questions for Andrey? Don't see any. Well, you can always write him an email or what you had there, the Twitter. Twitter hashtag.
So you can ask me. I have a web form on my blog, so you can ask me via Facebook or Twitter. So please ask me, and I will help you if I can.
Good. Thank you, Andrey.
Okay.
It was an awesome session. I've really enjoyed it. And everyone on the line, thanks for coming. I will be sending out the link to the recording. Please send it to your friends because it's a nice session. Thank you very much. And have a good evening or day, wherever you're joining from. Bye-bye.
Okay. Thank you, Maria. Thank you for listening. Okay. Goodbye.
Thank you. Goodbye.